Alright, so for this video series, I'm just going to get crazy a little bit. I got the idea the other day to make an isometric game in Java, and we're just going to try it out. I really wouldn't call this a tutorial series, though I'll be talking about everything I do as I do it, and maybe you can get something out of it. Hopefully, I think that you'll find the technique we're going to use here is very simple and user-friendly, and maybe you can apply it in some way to make a game of your own. Anyways, we're just going to have a little bit of fun with it. So let's get right to it. I just have a little starter LibGdx project here with the normal two classes that it generates for you, the desktop launcher and your main game class. I've done nothing to the desktop launcher. I've just made this extend game and sort of set up the sprite batch so that it's ready to go. First, I think we're going to just make a class that's going to be a game screen class. Really, all we're going to do today is we're just going to get right in and hammer out some stuff. We'll worry about like menus and making it a real game a little bit later. Today I just want to get in and see if it works and do some sort of fun stuff. Get a little bit of the isometric going. Cool, let's just get crazy. Anyways, we're going to make a game screen here. Aha. And then cool. And we know that this main game class delegates to screens. LibGdx sort of works on a system of screens. You just have your screens extend screen adapter, and then that screen adapter parent class will give you everything you need to sort of make a game. Yep, and this should be good to go now. Is it still mad? Yep, because we have to save that. So let's make a... Later we'll probably have it delegate straight to a menu screen or something, like a main menu, but for now we're just going to go straight into the game so we can see if some stuff works. We need our sprite batch here. With LibGdx, you always have pass the sprite batch around wherever it's needed. It does all the rendering for you. As you'll see, you never want more than one sprite batch. You just pass the one around from your main game class. Cool. It's just some Java stuff. Help with the compiler make sense of all this, taking the ambiguity out with the this, the keyword. And here we go with the stuff that really makes it the screens a game, stuff like public void show. And that just runs before your first game loop, or for your first render loop, which basically is the game loop in LibGdx, right? Game engines usually have some sort of, or I guess maybe always have some sort of underlying game loop that runs a certain amount of times per second, certain amount of frames per second. The render loop for LibGdx is this loop, and it even gives you the time between frames or whatever. So that way you can have input that is system independent. It'll, on a fast computer, your game will move at the same speed as on a slower computer. Cool, so that's what the render loop is. It's just the sort of main game loop. It's going to run 60 times per second, 60 frames per second, I guess. Cool, and then we have dispose, so you can get rid of all your assets and stuff, avoid memory leaks, things like that. We'll mess with that a little bit later. So what do we need here? Well, I know we need a camera for our game. Cool, so that we can look into our world. And let's go ahead and make the instance of it. And what size do we want it to be? I did not spell that right. And that needs to be lowercase. Okay, so what should size of it be? Well, let's make some variables to sort of state that. Make these public, static, and final. Final, and let's give ourselves like a And yes, I know I didn't give that variable a name. Let's give ourselves like a 16:9 aspect ratio or something. I don't feel like thinking about it for bigger numbers, so we're just going to multiply that by 4 and let it be. And then we're going to put that in here. There you go. Now we have the width and height of our camera, which we want to be the size of our screen so that we can look through our camera into the world. Even if you didn't have the camera, you'd still be able to look into your world. You just wouldn't be able to look anywhere except for the starting position. But with a camera, if something's off screen, we can actually move to look at it, right? We can move the camera around to follow the player, follow whatever we want. Without the camera, we couldn't do that. We would just be looking at one static part of the sort of game. Cool, we're setting our camera to the middle of the screen. Let's set the Z value at 10. We may mess with that later. This isn't a 3D game, right? So we're not going to have to mess with it too much. Cool, what else do we need here? Well, we need to clear the screen and the render loop. I'm actually just going to copy that over from some other code I have. I don't actually commit this clear the screen code to memory. I just always kind of copy paste it. Cool. So, and we're going to tell the batch what it should be projecting to. That's our camera. Don't really have to worry about the underlying implementation of this. The great thing about using a framework like LibGdx is that we can just use its camera without having to worry about all the matrices and other things underneath that go into sort of something like this. We're also going to update our camera every frame. We're going to begin drawing with the sprite batch. We're going to end drawing with the sprite batch. Like I said, all rendering, that's not one. All rendering LibGdx is done by the sprite batch. Alright, what do we want now? What are you mad about? Oh yeah, gotta actually pass our batch in. So let's go back over here too. Let's set up our configuration for the screen. This configuration application here is how you actually set the width and height of your screen. So we'll just go ahead and set it to game screen.width. That's not what I wanted. Alright, cool. And now, if we run it, we should magically have a black screen. We do magically have a black screen and a nice aspect ratio. Cool, let's get crazy. Let's do some stuff here. So I think we're gonna make an isometric. Jesus. I try to type too fast and I'm typing everything wrong. Make a little isometric renderer class. This is not going to extend anything, I don't think. Public. Renderer. Cool. What do we need in here? Well, I have some sort of assets I've picked out. I like this isometric grass tile here, and I just got it off OpenGameArt. I also have like a sky background I'm using at some point. I even have like a little person here that we'll use later. I don't know if these assets are going to be what I'm going to use throughout the whole thing, but for now they'll work. So we're going to make a texture here for the grass. Textures in LibGdx are just 2D images essentially, and the texture class holds them and gives us like some really convenient methods and stuff we can use for drawing them to the screen. This just takes the hassle out of like having to manually handle 2D images yourself, like you would if you were to build your own game engine instead of using LibGdx. New texture. Cool, so I believe the correct way to access Your assets is like this with the gdx.files.internal. And then size and texture. We'll just copy this portion. Cool. We are going to make a public void. Let's just make a draw ground. Let's just draw the ground today. Let's see if we can get some isometric stuff going. And how are we going to do that? Well, we're going to have like a double for loop. We're going to pass our sprite batch in here for drawing. Like I said, sprite batch gets passed around wherever it is needed. And what are we going to do here? Let's see. I know a lot of people would just call this like I'm going to call it row. I think that's just like a little bit more semantic or whatever. I just find it to be like a more useful naming convention than calling it I, because it is the row. You're looping through sort of rows and columns, right? In a sort of theoretical 2D array. We could make an actual 2D array to loop through that and then have it with like zeros, ones, twos, all kinds of things, or even make like a enumeration and have it be even more semantic than that. And then that represents our map. You know, we could have like, okay, a 0 represents a hole, and then a 1 represents a I don't know, a hill, and a 2 represents just flat grass or something. And we might do that later, but today I'm just going to have the code generate sort of a little isometric area for me, and we'll see if we like it. I'm a little bit lazy. I want the code to generate it for me, right? I don't want to have to write out a big 2D array or whatever. And it's just going to be 15 by 15. And we might keep with this method, we might not. You could just make an isometric map ahead of time, right, in some type of tile map editor, like I have tiled down here. And then you could just put it in your game, put your player on top of it, and do the player movement in such a way that the player would know that it is, isometric movement and that it is an isometric game. And that might be the best option, but that is not what we're going to do for these videos. Because like I said, I want to show you all a simple way that you can do it just through code. If you like it, you're welcome to use it. If not, it's up to you too. What do we need here? Actually, we need, and let's just make them public static final variables. Public static final int. We need a tile width and height. So we have our little grass tile there, and we can decide how big that's going to be. I think it's 34, so we're just going to go with 34. By 34. I'm pretty sure this grass tile is square, as tall as it is wide, and that's what we're going to go with. And we'll make sure of that here in a second. So tile width divided by 2, because we want to center it. We want to go from the middle of it rather than the left side of it, and then rather than from the top left corner. Typically, I believe LibGdx calculates positions for textures from their top left corner. We want to calculate it from sort of the center. So that's what we're going to do. And if this math is a little bit confusing, just, once it starts appearing on the screen, I would suggest just think about it a bit. It's not too bad. Like I said, this is about all the math we're going to do. Like, this is about as complicated as it's going to get calculating our X and Y position for the isometric tiles. And it's not very complicated, huh? Let's make that a float. Cool. And then we're going to take the batch and we're just going to draw with it. Man, that's magic, huh? Just drawing with it. Okay, so we want, with the batch.draw, you can tell it lots of things. We're just going to tell it these 5 things. We're going to tell it our texture, its X position, its Y position. I assume pretty much everybody knows like coordinate systems. like a basic like Cartesian coordinate system. Yeah, like everybody learns it in high school, right? So cool. And then we're telling it the size. Actually, I made a variable for that, as a matter of fact. Yeah, that way we know for sure it's going to be square. All right, let's go over to our game screen. Let's make a private Isometric Renderer. Let's just call it Renderer. Let's put it in here. Renderer is new. Isometric Renderer. Cool. And then we're going to access its draw ground method, pass in the batch, and we should see some magic happen, I think. Or maybe the game will crash, I don't know, let's see. Ooh, that is not what we wanted, huh? There's something going on here. Some good things. Let me see. Look at this. Okay, that's silly. I'm silly. All right, that was real dumb. Cool. Too much in a rush, you know. So we have sort of a map here, right? But it's not quite what we want. So let me do something first. Let's put the camera over. Let's say, okay, yeah. Let's experiment with the camera until we can see the whole. All right. Okay. All right. Let's just do something like this. There we go. So until we can just see the whole thing, and we'll play with these numbers later, right? We can like min-max these numbers and get it the zoom level of the camera and everything. By the way, doing zoom in LibGdx is like the easiest thing ever for the cameras. You just access the not input, or no, it is input. Yeah. You just access their sort of input system, and then you access the keys, and then just tell it what key you want. We'll say Z, and then this is how easy zoom is. You're literally just gonna access zoom directly like that, and then to zoom in, you're just gonna add to it. Let's add like 0.5, and I think that might be a float. That might have to be a float value. All right, and then we'll zoom in a little bit. Now I know what you're thinking. Ooh, actually, that was in fact a zoom out. Also, let's drastically lower this number a little bit. Now I know what you're thinking. We really should be multiplying this, okay, by the float delta to make it like not, okay, cool. And we could move our camera other ways too. So I know what you're thinking here. Why is it all uneven like this? Right now it looks like we have some weird elevation, like our player would be moving up a hill or something. And that's actually pretty cool. Maybe we can do something with that later. But right now we want it to be sort of flat. Let's see. I think it has something to do with this, right? We want our tile to be lower. So I think 4 is right there. Now, there we go. This kind of makes sense, right? Now we have like a nice little isometric ground, separation between the tiles. If you want to, you can play with these numbers a little bit and maybe try to get the tiles exactly matched together. Personally, I kind of like this separation. It gives me like a little bit of a grid or something. And I don't think we're going to be looking at the edges too much anyways. I kind of like this separation, this little grid here, so the player sort of knows where the tiles are. Anyways, it's kind of fun, but we'll think about it as we go on. Either way, I do think we have something going here. So just like that, in what, 1, 2, 3, 4, 5, maybe 6 lines of code, we've already got some stuff rendering, right? We've already got these like tiles down. If we put a player in here, we could like move around. If we had a little enemy in here, maybe we could make him move randomly looking for the player or something. We're on our way. Either way, I think this is going to build into something cool. Video's been going on for about 21 minutes now. I don't want to bloat it too much. Anyways, I think this is going to be a fun project. It hasn't, we haven't done much with it yet, but we will. As always, though, I hope you've already gotten something out of this. Maybe you can leverage this code and maybe there's some people who are a little bit better at math than me out there who have read a little bit more about isometric stuff and can leverage this code and do better. That'd be awesome. Let me know in the comments. Also, if this confuses you, let me know in the comments, and maybe I can find a way to help you understand it better. Anyways, I will see you in the next one.